everybody. So till now we have done all the array part, in which we have seen what is an array. We have also studied about basic of data structures. Okay, so from today I will be also discussing some DSA problems, and we will start with the basic problem from array because we have finished arrays basic part. So we'll deeper dive into a deeper concept and various things and algorithms. Okay, so let's start with reverse an array question, and which is the DSA problem. Okay, so the approaches are, we can iterate the array from backwards. Okay, and then we can go till front and make a new array by copying the previous elements, or we can use two pointer approach. So you all be thinking, what is two pointer? For now you can take that we will make two pointers pointing from first and then pointing last element of the array, and we will make it same, and till then we can do all the things we wanted to do. So don't worry till now if you're not getting it's not so to think to worry. We'll take it into later slides. Okay, so let's talk about iterate and make new array into Eclipse. So here we are with our array 23 14 6 2 7. So what we want in result is 7 2 6 14 and 23, right? So what we will be doing, we'll talk about the first approach that I have told you, that we will iterate from a backward. So first we will make a new array called B, and we will initialize it with the length same as A. Okay. Then we will make a for loop starting from end of array A element until we reach the first element by decrementing it. Okay, till now this is the for loop that I have told you. We will move from backwards of the array. Then we will make an index which will be pointing to array B, which is indexing for B array. Okay, so we will take B index equals to AI. Okay, so this is the basic thing that I have done. Now I can print parent I in B. I don't need this curly braces, and will print B. Okay, so this is the basic thing, the naive approach of to this problem. Okay, then here I have forgotten to increment the index. Okay, so now we'll run it and see what is the result. There is something fishy going on. Let me run again. Okay, I got the answer as this: 7 to 6 14 23. So this was a naive approach. Okay, so now we'll go back to our PPT and discuss about the time complexity and space complexity for both of these. So time complexity, big O of n. As you can see here, we have made a for loop here. Don't consider this for loop. This is for printing. We can return also. We'll consider this for loop because here is the our main functioning of the program. Okay, so this is the main. So this is big O of n because it is iterating till the length of the array. Okay, and space complexity, we'll look at space complexity big O of n. How it is big O of n? Because we have declared an array B with the same length as big as of array A. So this is all discussion about time and space complexity of the approach. Now let's move to two pointer approach. Here are two methods of two pointer. This is not related to our problem right now. I will be focusing on two pointer only. What is two pointer and all thing about it. So two pointer have two methods. First, we will mark the two pointers from end and beginning. Here we have 41 as start and 3 as end. We will make two pointers and slowly move the beginning pointer towards end and end pointer towards beginning until the until both of them reach to a single destination. Odd single also, but here are odd number of terms. When there are even number of terms, then we will see they will not reach both the same. No, sorry, they will reach at both at the same destination. This is only a two pointer concept. Okay, so the second is we will make one slow pointer and one is fast. You will not be able to see the application right now of this because its main application come in linked list when we have to mainly point out whether the linked list is cyclic or not. That is the main concept that is used there. Okay, so now let's move towards the eclipse and see the two pointer approach. Let me comment this out. Okay, don't worry for the code. I will give the link in the description for my GitHub. You can see all code from there. And if you have any sort of doubt, please comment down below or also on the Git repository. Okay, so we'll make a pointer I. Let us make a pointer start 0 and end as a dot length -1. Okay, so we'll move till. Okay, let me take you to the whiteboard only how this is working. We want it to reverse. Okay, so what we will do, we'll make a start pointer here and a end pointer here. Okay, as you can see, I made it this. Then I will swap these terms. I will swap these terms, these both. Okay, then I will increment this I and I will decrement j. Okay, and I will decrement. I will move this pointer here and then again I will swap. Okay, so when we come here, we don't need to swap here and we will still increment this and decrement this, and it will work till I is lesser than j. But here I is not lesser than j, then here no swapping will be done and we have come to a result. So what we will do get after swapping, we will get here 3 1 6 3 41. Okay, if you're not getting it, let me explain it again. What I have done, let me clear all this. I have taken a pointer at the starting pointing to the first element and the second pointer pointing to the last element. And then I will swap. I will check whether this pointer is lesser than this pointer value. So if it is done, then I will swap. Okay, and I will make this 3 and make this as 41. Okay, then I will do again increment the pointer here, increment the pointer here. Again I will increment the pointer here. Okay, then I will decrement again here. Then I will swap again these both. Okay, then 1 will come here and 3 will go there. Okay, then again I will increment this pointer, start pointer, and decrement the end pointer. Now I can see that these both are at the same place and I is equal to j. The condition is not satisfied. Now no swapping will occur. Okay, so now let's move to Eclipse and start coding. While start pointer is lesser than end pointer, then only this will happen, and we will make a temporary variable temp and store start here, and we are swapping here. Okay, a end, and then a end will be equal to temp. Then here swapping has occurred, then we will print the value of I because we have in place only. In places when we don't need any extra memory space and we'll change the values within the same array. So that term is in place. So now let's run and check whether result, yes, our result is same according to this. So this is the basic strategy that we will be using to solve this question. Now let's move towards our PPT. Now we will discuss about the time complexity. Time complexity big O of n. As you can see, we are moving from within an array only, and basically it is n by 2, but we know there is no term n by 2 in time complexity, so we round off to big O of n only. Okay, and time space complexity is equals to 1 only because you have not taken any sort of array or anything else as a space complexity which will be creating some sort of extra space. So this solution is better than the first approach. As you can see that space and time complexity both were big O of n. Okay, so thank you everyone, and if you have any doubt please comment down below. Thank you everyone.